So the organizers asked me to spend the first couple minutes talking about my career trajectory, and it seems like COVID is the perfect time to be kind of introspective and think about where you've come from and where you're going. So I'm happy to do that. I majored in economics in undergrad, as an undergrad, and unlike a lot of people today, I'd never taken an economics class in high school. It wasn't offered. But I really loved economics. It just kind of felt like it helped me see the world through a mathematical lens, and I'd always loved math, and it let me study things that I was interested in. Between college and grad school, I worked for an economic consulting firm, and then I left that and worked for the Department of Public Utilities, the regulator, basically the equivalent of the California Public Utilities Commission in Massachusetts. And that was, to me, that was like the best career choice I've ever made. The economic consulting firm, I was doing data entry and not very fun work. The cases were kind of interesting, but the work I was doing was not very interesting. While working in the public sector, they basically like gave me as much responsibility as I was willing to take. So yeah, I especially for people that are at kind of an early stage in your career, I highly recommend public sector opportunities. To me, that was really fun and really eye-opening. At that point, I was deciding whether to go to grad school in economics or go to law school. My dad is a law professor and basically kind of discouraged me from going into law. He saw that it wasn't a great career choice for a lot of women, that people were, being forced to make compromises in either their work life or their family life as they tried to make partner. So he didn't have to do too much nudging, but he was pretty instrumental in weighing the scales in favor of the econ grad school. I went to MIT, and I basically went knowing that I wanted to study energy economics because I'd worked for the Department of Public Utilities and been regulating electric utilities, and seeing how much the academics influenced like real actual policy decisions. And so I went to MIT and I studied with Paul Jaskow, who was a phenomenal advisor and has been an important mentor and supporter to me since then. And basically, like, once you get into academics, you have a lot of freedom to choose what you want to study, which is one of the reasons I love my job, that you can just decide, as I did about 10 years ago, I want to reshift the focus of my research and start thinking about a totally different area of the world. I had been studying the UK, mostly the US, but I just decided that there wasn't enough existing work on energy in emerging markets. And so I wanted to try to contribute to that literature. And I didn't have to check with a boss or get anyone's approval to do that. I could just make that decision and do it myself. So while you have a lot of flexibility on what you study, there's not that much, there aren't many decisions to make about your career path. You just try to write as many papers as you can, try to get tenure, if you're in the UC system, you have to continue trying to get like full, and yeah, there are lots of benchmarks along the way, or lots of hurdles along the way. So yeah, I love being an academic. I love studying this area, energy. I think it's an area where, in particular, academics have a lot of influence on policy, kind of real life policy decisions. So happy to chat further. I guess, okay, I wanted to say two more things. I think both in economics and in energy, definitely when I got into things about 25 years ago, there were not many women. And at first I was kind of oblivious to that. Like, I would notice that I would be in a meeting and there wouldn't be any other women, but I wasn't as attuned to, I guess, what people now call microaggressions, or people treating me differently. And in some ways, I guess that was good, because it just made me, whatever, forge on. But, looking back, I think there were some times that it would have been helpful for me to know that it wasn't personal, that people were saying things because they were not used to having a woman, you know, in their environment. So, and just as like one very, very recent example, I was at a conference and a colleague of mine was presenting our paper. This was like literally within the past couple of weeks. And there are 3 of us on the paper, and somebody in the chat said, well, Paul and Brett, what do you think of this? And it was kind of like, hello, I'm a co-author on the paper too. So now I know to interpret that as just that person being whatever, not thinking very hard. Probably earlier in my career, I would have stopped and think, well, why, you know, do they really think I'm not contributing to the paper? What is it? What did I do? And would tend to blame myself more. But yeah, I guess I just thought I would address that, since energy is a field that where there are not that many women, and economics is a field where there are not that many women. So the overlap, it's definitely the case. And in addition to Paul Joskow as a mentor, I've had Nancy Rose. She was on my dissertation committee and an important mentor. Severin Borenstein at UC Berkeley basically hired me and has been a really important mentor. And since I'm talking to a Davis crowd, I need to mention Jim Bushnell. It's, you know, it's not quite a mentor, kind of a peer, but an important collaborator and friend for a long time. All right, so I'm going to turn now to the subject matter and talk about work that I've been doing on energy in emerging markets, and particularly in Africa. And what I'm going to do is spend probably like do a pretty long extended introduction. Eventually, I'm going to get to talking about reliability and talking about electricity quality, but I really want to motivate that by talking about some other work that I've done on electrification. Oops. Okay, so just to set the stage, this is a graph that measures total energy consumption. So taking oil, electricity, natural gas, converting everything into BTU, British thermal units, and plotting energy consumption in the emerging markets in the non-OECD and energy consumption in the OECD. And so you can see that the emerging markets have already passed the OECD, the developed world. That happened back in about 2006. This is in terms of total, not per capita energy consumption. And I think importantly, the energy consumption over the next 30 years is primarily going to be, the growth in energy consumption is primarily going to be from these non-OECD countries. And so if you're interested in climate change, if you're interested in understanding world oil markets, you really need to understand what's happening in these non-OECD countries, in the emerging markets. Because by 2050, two-thirds of the energy consumption is projected to come from those areas. If you look in my field at the ratio of papers, it's way, way disproportionately in OECD countries. That's where the good data are. That's where a lot of the academics are. And so, you know, the bulk, I would guess it's like 98% and 2%. The bulk of the work has been on OECD countries. And so clearly that's an imbalance. And that's something where if we want to think about how carbon mitigation strategies are going to be received in the important markets where the energy growth is happening, we really need to understand those markets. And so, you know, this is a basic fact that has motivated my shift into thinking about energy in emerging markets. So if you're thinking about climate change, seeing any kind of upward sloping graph like that is a little scary, but I think it's important to emphasize that energy growth and energy consumption from a development perspective is potentially a really good thing. So this is a graph where every dot is an individual country. The yellow ones are the most populous countries. And I've plotted countries in terms of their GDP per capita and their electricity consumption per capita. So now we're drilling down on electricity, not just thinking about total energy. And in economics, there are not many relationships that are this clearly kind of positive and you know, this clearly upward sloping. If you were to run a regression on that, just this one explanatory variable, the R squared is like, 0.85. And there are really not that many relationships where it's that clear. And I think a lot of policymakers have interpreted this to say that we need to drive energy consumption because that's going to increase GDP per capita. That have interpreted that to suggest that basically electricity consumption causes economic development. And so we need to figure out how to get people electrified, how to increase electricity consumption in order to drive GDP per capita. And that's just one measure of economic development. You can think of others, but they would similarly be very positively correlated with electricity consumption. So I've kind of purposely drawn it the opposite way because at a basic level, we don't know whether electricity consumption drives economic development or whether economic development drives electricity consumption. It could be that as we get richer, we are rich enough to demand things like air conditioning, rich enough to do things like, drive our cars more. And so it could be that it's not electricity consumption driving GDP per capita, but it's the opposite. And that's a really important kind of fundamental distinction to try to unravel. If we don't even know like which way the causality goes, then we have a lot to learn. And so that's what's been motivating some of my early work on electricity in emerging markets. So if you go to conferences on energy in the developing world, very, very quickly, if you read papers, if you read policy briefs, very, very quickly, you'll see this statistic that there are approximately 1 billion people who live without electricity in their home. And often this is followed by, we need to get these people electricity in order to promote development. So thinking back to that graph, the policymakers, the donors, the multilateral development banks are thinking, okay, we need to move people along that positive graph, or that positive slope in the graph that I just showed you. We need people to be able to consume electricity so that they can develop. But I wanted to investigate, to the extent, or to what extent that was the case. And often, policymakers will follow this thought about bringing people electricity with the idea, well, the kids will study more at night, or people will be able to refrigerate medicine. They tell themselves stories about what happens once you bring electricity to people's homes. But we don't have that much on the ground evidence of what happens. And so I wanted to start to address that. In order to do that, I worked with a couple of colleagues, Ted Miguel at Berkeley, Ken Lee at Berkeley then, now at the University of Chicago, and we did a randomized control trial. We wanted to basically randomly bring some households electricity and not others, and then compare them. I know we've heard a lot about randomized control trials with the vaccine trials that we're all following closely. Basically, we're applying that to the context of electrification. So let me explain to you how that worked. This is one slide on methodology, but I think it's important to understand. So we started with 150 what we were calling transformer communities. We identified people who lived within 400 meters of an existing electricity transformer. And then literally randomly, like literally flipping a coin, we divided them into the treatment group and the control group. And since you've done that randomly, then these two groups are statistically identical because every community had an equal chance of being in either the treatment or the control group. And so if they're statistically identical, they've got the same number of people who want to be entrepreneurs, the same the same existing levels of wealth, the same kind of baseline health, baseline water and sanitation. So that's the nice thing about doing this randomization. In the control group, we surveyed them at the beginning, we surveyed them at the end, but basically kind of let them live their lives in between. And in the treatment group, you see I've got 3 colors here. We offered 3 different levels of subsidy for them to connect to the electricity grid. So, oh no, we have the gardeners here with the leaf blower. Hopefully it's not too distracting, but Okay, so the communities that are colored black here, we gave them a free electricity connection. It was, until we came in with the free subsidy, it was $400. And this is in an area of the world where average annual income is about $800. So we were giving them the electricity connection for free. And the green and the red, we gave them like a 60% subsidy or a 30% subsidy. So, you know, in the green group, they had to pay about $130 out of the $400. In the red group, they had to pay more, like $270. And then we went back. We went back 18 months later. We went back 3 years later, and we've just gone back now 5 years later. Here I've got it as 2 years, T equals 2. And what we're going to do is compare outcomes in the treated group versus the control group. So are we seeing kids studying more at night if we've subsidized an electricity connection for them? You know, are we seeing these outcomes? Are we seeing the more use of refrigerated medicine? Are we seeing people starting businesses with their new electricity connection? What on the ground are we observing is the impact of electricity? In the control group, there were a couple households that were willing to pay the $400 to get connected. But basically what the methodology is doing is using our intervention, our subsidy of the electricity connection, to compare the treatment group where there are a much larger share of people with electricity to the control group and measure the effects of the electricity connection. Okay, so here's how we implemented it. We were working with a local NGO, Innovations for Poverty Action. They're very well known. This is in, excuse me, in Western Kenya. It's kind of a rural but densely populated area of the country. Innovations for Poverty Action is very well known there. So, you know, here we are explaining to a group of households that were in one of the red or green treatment areas where they had to actually pay money. And so we're explaining how they go about that process. Like they had to bring money to the bank, come back with the deposit slip and show us that they'd submitted their part of the electricity connection price. Okay, step 2 was that the Rural Electrification Agency put up the poles, they strung the wires, they had the drop-down cables going to the individual houses. I was there not on this day, but on the day that we connected our very first household, and it was thrilling. There were a bunch of neighborhood kids watching the engineers put up the poles and drop down the wires. We all kind of watched as they screwed in the light bulb. The first time it didn't work, so they kind of jimmied the wires or fiddled with the wires. They screwed in the light bulb and there was light, and everyone was, you know, excited. And the house had a TV already. They were you know, all ready to start operating their TV. So that's kind of the second step. The third step here is a picture of the Kenya Power, the gentleman from Kenya Power explaining to the homeowner how to work the prepaid meter, because all of the people that we connected, they received a prepaid meter that came preloaded with about 30 kilowatt hours of consumption, the value equal to about 30 kilowatt hours of consumption. I also wanted to show this picture because it shows this, what we called the ready board. We were a little bit afraid that we would pay all this money to get people connected to the grid, and then they wouldn't have enough money to do the internal wiring of their house. And so we provided people the option to, as part of the study, get these ready boards, which came like with one light bulb socket or light socket and a couple you know, plugs for cell phone charging, so that at least they would have the ability to have lighting and cell phone charging. If they couldn't afford to do the internal wiring, at least they would have this. All right, so we ran this big experiment. We got a lot of grant funding. We raised a lot of grant funding to pay for people's electricity connection. We did surveys beforehand to get a sense for people's kind of baseline experience, baseline way of life. We surveyed them after the fact, after they'd had electricity for a number of years. And we found basically no impact, no difference between the control group and the treatment group. To me personally, this was pretty heartbreaking on a like emotional level, that it just didn't seem like this was transforming people's lives or changing people's lives. And, you know, in part I'm disappointed for the people, in part I'm disappointed that my area of development doesn't seem to be having much of an impact on people's lives. But on a researcher academic from a researcher academic perspective, it was fascinating. It's just an issue that we need to, you know, you answer one question, but you raise 5 more questions. So what I mean by no impact is we were surveying the households after the fact. We went through like an hour-and-a-half long survey, asked them a battery of questions. But we wanted to be careful, because if you ask somebody, if you ask the treatment group 100 questions, you ask the control group 100 questions, and then compare them, just statistically speaking, you're going to find 5 answers where the treatment group is different from the control group. But that doesn't mean, that's just like a feature of statistical properties, or that'll just happen because of these statistical properties. We wanted to be careful of that. And so ahead of time, we pre-specified 10 outcomes that we thought were the most important. 2 of those outcomes were like, did you get an electricity connection and how much electricity were you using? Now, these outcomes are things that people conjecture will happen when a household gets access to electricity. So for instance, people say, if you have electricity, you can run a business. Now you can open a small micro enterprise. You can become a tailor, or you can open a haircutting shop or something. Or they say, these people will get out of the agrarian subsistence farming life, and they'll be able to enter the workforce. That by having electricity, it alleviates or reduces the amount of time that you spend on household chores and frees up time that you can spend in the workforce. We also look, this is like a nice economic summary of how well off a household is. We just basically ask, what are you consuming? How much meat are you consuming as part of your diet? How much, how many TVs have you bought? How many other things have you bought? We looked at similarly the asset value of the house. We looked at an index of health symptoms. We looked at how politically and socially aware people are. With all of these things, we found 0 difference between the treatment group and the control group. Finally, with the kids, we administered tests to the kids in both the treatment and the control group. We went in on Saturday and asked them to take reading tests in either Swahili or English, and asked them to take math tests. We saw no difference between the treatment group and the control group. The one kind of small ray of hope is that we did see that the treated group, the people that had received electricity, were happier in general. If we asked them on a scale of 1 to 10, how happy are you? They were, marginally higher in the treatment group. So overall, as I said, they're very small impacts of electrification. And to me, this picture kind of crystallized what's going on. This is a woman in one of our treatment groups proudly showing her meter, showing the prepaid meter that she got and the light switch that she had. She had done some of her own internal wiring. But you can see that she's living in a house that basically has mud walls. And so we're bringing electricity to people who live in places with mud floors and mud walls, who don't have access to sanitation, who don't have access to water, who don't have access to good health care for their kids, who don't have access to education for their kids. Basically, I worry that if you identify the 700 million or billion people in the world who don't have access to electricity in their homes, you're identifying the 700 million poorest people in the world, and they don't have access to many, many things. Some of those things are a lot harder to measure when they do get access to them. How do you measure whether or not you have access to good health care or have access to good sanitation? But electricity is this nice like binary measure. We can see when people have access to electricity, but I worry that we're confounding correlation with causation, there's correlation between the people who don't have access to electricity and are very poor, but that does not mean that bringing them electricity will make them not poor. It's just that it's correlated with it. It's not causal. And so I think, you know, seeing the fancy hardware on the mud wall, thinking about, you know, what actually can this woman do with her electricity, kind of helps put into perspective why we're getting those zero, you know, depressing results. So one thing that we saw, for instance, is that people in our treatment group used trivial amounts of electricity. They used about 3 kilowatt hours per month, whereas the average US household uses about 20 kilowatt hours, 25 kilowatt hours per day. So the people in our sample are using as much electricity in a month as the average US consumer uses in a couple hours in a day. And if you think about it, you know, if you're a subsistence farmer and if you're living on very little money per day, you just don't have enough money to buy appliances. People, we saw maybe one refrigerator amongst all our treated households. People were not buying refrigerators. So you can't refrigerate food, you can't refrigerate medicine if you can't afford to also buy the refrigerator. The electricity is not the solution. All right, so as I said, this raises a lot of additional questions. And one of the questions that I want to pose, and pose it in kind of a provocative way, but I think this will help us make the transition to talking about reliability, is, are we too focused on rural electrification? Is there a problem by devoting all this attention to the people, the billion people who don't have electricity in their home? And one concern I have, one kind of narrative that I will tell you where it could be a problem, is that we're diverting resources. We're spending a lot of money connecting people, like the woman that I just showed you, and thereby diverting resources from improving the reliability on the existing grid. So you might think, well, okay, you bring electricity to a very poor household, they don't use it, but it makes them happy. So, you know, at least that's something. And maybe in 5 years and 10 years, they'll start to use it. So like, what's the harm? But what I assert is that there's potentially a harm if by doing that, you're spending tons and tons of money building out the grid in rural areas and diverting money from improving reliability to your existing customers. So here's a picture that I took in the school on a Saturday when we were administering our test. You can see all the kids kind of curious, watching what's going on. But in the background, you can see this is a transformer, and these are the poles meant to support the transformer. They were leaning at a good like 75-degree angle. That I would not be shocked if a couple months after we were there, those poles fell over or the transformer fell over. So, you know, it's one thing to build out a system, but you also need to take care of the system. You also need to have the resources, if you're the electric utility, to maintain the system. Otherwise, the reliability is really going to falter. And the reason I worry about that is that, so I'll show you that graph in a second, but imagine that the real impact on rural Kenyans' lives is not getting electricity in their homes, but is getting electricity in the local factory. And therefore the factory can grow, they can have more jobs, and it employs the Kenyans in our sample. So maybe, you know, maybe the real impact of electricity isn't having it in your house per se, but it's having it at your local factory, at your local health center, so that you can get better healthcare delivery. If we're spending a lot of money, you know, the factory and the healthcare, the health clinic are probably already connected, but they will suffer if the reliability goes down. If the factory is experiencing poor reliability, then, you know, they're not going to be able to grow as much, and they're not as likely to employ as many people. And so potentially by spending money to connect people in their house, we're diverting money from an area that would really drive economic benefits for them. So that's my concern. Let me kind of put some numbers on this concern. This is a graph of Kenya Power accounts separated between residential, industrial, and commercial. The industrial are on a different scale here, the residential and commercial. These are thousands of accounts, industrial accounts. You know, in total in 2018, there were a few shy of 4,000 Kenya-wide. So what I'm showing you here is that there's just been an explosion in the number of residential connections in Kenya. We were doing our project to look at the impacts of rural residential connections a few years before. There were massive programs funded by the African Development Bank and funded by the World Bank to connect households. So you see that the number of household connections went from about 500,000 in 2001 to nearly 7 million in 2018. What's happened though is as Kenya Power has connected more and more people, they are using on average less and less electricity. So their average consumption in the residential sector has just fallen off a cliff. Basically, Kenya Power is connecting a bunch of households that are like those in our sample and that are using 3 kilowatt hours a month. And so the revenue that they're collecting from all these new residential customers is just not materializing. Meanwhile, their commercial and industrial customer base has not changed that much, but the commercial and industrial customer base, so I read recently that there are some 700 large commercial and industrial customers that account for 54% of Kenya Power's revenue. And so if you start spending a lot of resources, devoting a lot of attention to these residential and degrade the reliability to your existing commercial and industrial customers, it can have real negative impacts on both your revenue as Kenya Power, but also on the economy overall, if the commercial and industrial customers struggle with poor reliability, with electricity that's not very reliable. All right, so that's the concern, but in order to figure out how big a concern that is, we really need to understand the relationship between reliability and economic development, between reliability and how firms grow, how much they decide to employ people. So now I want to transition to the second part of the talk and talk about some ongoing work that I have looking at reliability. Okay, to motivate this is just an example of how important reliability is in many parts of Africa. This is a billboard from just outside the airport in Nairobi. It's an advertisement for a refrigerator. And the thing that they're emphasizing is that it has the longest cool air retention during blackouts. So blackouts are such an important part of people's lives that the main selling point for this refrigerator is that it will operate for 10 hours during a blackout. So, you know, just one indication that this is something that's very central to people's life and people's decisions about which appliances to buy. In order to learn more about reliability, though, we need to understand where reliability is high and where reliability is poor. And what this map shows you is that there are, you know, lots of places where we don't just basically have no visibility into reliability. What this is showing is on the scale, this is the SCADA, the system average indicator of, or it's about the duration of outages that you see. So you can see that in the US, we average about, I think, 2 to 3 hours of outages per year. This is showing you that in Nigeria, Libya, Pakistan, Kenya, for instance, the number of outages are closer to 500 hours per year. But what it also shows you is that in a lot of Africa, we have no data on outages. We just don't know what the reliability situation is. I also showed a similar graph or a similar map during a conference in Ghana, and people pointed out, wait a minute, the DRC looks the same as the US, that's gotta be wrong. So even in places where we think we have data, people are very suspicious of the reliability of those data or the accuracy of those data. So, you know, basically, I would like to understand reliability. I would like to know more about how reliability drives economic development, but that's a problem if I can't even get the most basic data at a country level on reliability. It's a problem for me as a researcher because I can't measure the benefits of reliability. You know, I think even more important, it's a problem for donors because they're investing a lot on the reliability work that I'm doing. I've been working with the Millennium Challenge Corporation. For instance, we're working on them with a $500 million investment in Ghana to improve the reliability of their system. But if they're spending all this money and then they can't see, they don't have any visibility, then they can't measure how well those investments are panning out. I think most importantly, though, if the utilities don't know what the reliability looks like, there are real problems running their system. You know, they can't optimize how they dispatch their repair teams. They can't respond in a timely manner. They basically don't know that there's an outage until somebody calls them to tell them that there's an outage. And they can't do kind of some of this predictive, avoiding future outages by predicting failures. I think most importantly, though, they start losing customers. If their reliability degrades, these customers will buy backup generators, will buy solar power, and will start supplying themselves electricity. And so the utilities kind of get into this death spiral of losing customers and then having poor reliability, and then that reliability drives away even more customers. All right, so in search of good data on reliability, I've teamed up with some engineers at UC Berkeley who have devised a number of, I think, really ingenious ways to try to measure reliability. I'm going to explain it in one slide, or try to explain it in one slide. I'm happy to talk more in the Q&A, or I'm happy to put anyone who's interested in touch with engineers and they can explain the engineering details. The first thing that I think was very high on the ingenious scale, unfortunately became hard to operationalize, was to try to use smartphones as a way to measure reliability. And basically smartphones are picking up a lot of, are kind of sensors that are picking up a lot of information about the environment around them that can tell you about whether or not the electricity is working. So for instance, it's picking up, if it's plugged in and charging, it's picking up whether there's electricity charging the phone. It's also picking up, even if it's not plugged in and charging, whether the Wi-Fi signals are there, or the engineers that I'm working with had kind of tuned the microphone to drown out all the ambient noise, but listen for the harmonic hum of electricity. So that seemed promising, quite promising, especially given the density of smartphone usage in a lot of urban areas in Africa. But I think Google did something with the API that made it difficult for them to access all the indicators, all the kind of sensing information that they wanted to. So they also developed basically something like the phone that is sensing the Wi-Fi, that is sensing whether it's plugged in, but where they control the software and where they control it. So we're embarking on a big program in Accra, Ghana, in the major urban center in Ghana, to deploy hopefully about 1,500 of these PowerWatch devices. The third thing that they're doing is basically collecting the information from the phones and more from the PowerWatch devices, and doing machine learning algorithms trying to identify when there is an outage. So let me give you kind of a quick schematic of what the idea is behind this approach. This is a very rough schematic. I'm sure you've seen stuff like this of an electricity distribution system, and here's the generation. There's some high voltage transmission to the substation, some medium voltage transmission to the big transformers, then smaller transformers, and eventually houses and businesses on the low voltage system. And so what the idea is, you deploy some of the GridWatch devices or the phones, if you can get the phones working, deploy them to the customers. They're at the customer level. You don't need the cooperation of the utility because these are in the customer's homes. And then if you see all of the GridWatch devices on the system go down within milliseconds of one another, you can infer, this is kind of the cartoon version of what the machine learning algorithm is doing, but you infer that there is an outage, that there's a high voltage outage. Similarly, if you see these 4 devices go down, and if you've mapped them to the transformers and you know that those transformers are on the same feeder, you can say that there's a medium voltage outage, and then this GridWatch device is on. And similarly, if you see just 2 devices that are at the same kind of on the same transformer go down, these 2 nearby but on a different transformer don't go down, you infer that there's not an outage. And they're optimizing, they figured out that if you deploy about 3 devices per transformer, then you have very good visibility on even the LV outages. If you have too few, then you confound people unplugging it, or something going wrong with a particular device with an outage. So you need to have some redundancy built in at the transformer level. What the utility is collecting is through a SCADA system. So they're collecting pretty good data on HV and MV outages, but they do not have visibility into their LV outages. And so let me show you what we are seeing in kind of the early days of collecting these data through the GridWatch system. Actually, so first of all, here's just a picture of a bunch of the PowerWatch devices that get plugged in the engineers' labs. We're working with a field team in Ghana that are going to the households and the businesses and asking people to plug them in, explaining the compensation scheme for leaving the device plugged in. We also deliver power strips so that people can, they don't lose a plug by having the GridWatch device in their house. Okay, so here's some very preliminary data. Here I'm looking at SAFE, the System Average Interruption Frequency Index. So before it was thinking about duration of outages, now this is just the frequency of outages. This is for one district, one of the utilities districts in Accra, last July, August, and September. So first, what I want to do is show you what the utility collected on outages in this district in these months, and then I'll show you how that maps to what the GridWatch devices collected. So basically, the utility thinks that there were high voltage outages that on average, there were about 2.5 of them for the customers in this district in Accra in July, slightly more in September. Then there were slightly more medium voltage outages, but really not many compared to the high voltage outages. And then, like vanishingly small number of LV low voltage outages. So what do we see with the GridWatch devices? We see about the same in terms of what the GridWatch devices think are MV and HV outages. So outages that affect a large number of transformers, or at the feeder level and higher. So that's kind of encouraging that the GridWatch device is matching what the SCADA device is seeing. If anything, maybe the SCADA device is seeing too few, or maybe the GridWatch device is seeing too many. This is early days in their algorithms. They'll figure out which of those is the case. But what's really interesting is the utility seems to be missing about 50% in July, maybe 40% in September of the outages. That there are a lot of small outages on the LV system. We suspect what's going on, we need to dig into this further, we have an ongoing experiment, is that the LV outages are seen by the district office. The district office deploys their trucks to address, like there's a transformer fuse that blows, but they don't report that to the central office. And so, the statistics that the central office is collecting, the statistics that they're reporting to the World Bank, the statistics that are informing how good their transformers are and at what level they need to be repairing transformers, that the utility is just not seeing. So, I think in some ways, this is depressing because the utility has so little visibility into it. In some ways, I think that's pretty encouraging because, as I said, obviously somebody is seeing these outages and addressing them. So it seems like there's just kind of a managerial or organizational issue that needs to be fixed, and so that these outages get reported out. Okay, so I'm going to conclude and then happy to answer questions. I guess at a high level, I would emphasize that what our research is showing is that the relationship between energy and economic growth is much more complicated than these country level correlations suggest. It's not clear that for poor rural agrarian people living in subsistence farming, that bringing them electricity leads to more economic development, or even like leads to potential economic development if their kids are studying. We're just not seeing that, and so we need to think about, you know, what type of electricity is it? Is it electricity that provides growth opportunities for firms? Is it electricity that supplies healthcare centers? You know, what is it that leads to economic development? Or is it, as I said, just a reverse causality thing? Is it that as people get richer, they like electricity and they decide to consume more of it? I think kind of bringing this back to California and thinking about all the efforts that hopefully we'll see in the Biden administration to address climate change, I guess I would just hammer home the point that we need to study energy systems in other parts of the world, and we need to think about how what we're doing in the US, how that translates into other parts of the world, and in particular Africa, India, and China, where this explosion in energy consumption is forecasted, projected to happen. Because basically, like, we can sell ourselves Teslas all we want for people that live in very nice, modern suburban homes in California, but meanwhile, there's tons and tons of energy consumed in traffic jams in Nairobi. Their trucks, their buses. You know, we need to think about, is this Tesla gonna address these transportation energy needs in places like Nairobi? And if it isn't, you know, we're really limiting the carbon mitigation strategies that we're pursuing. If they're not going to translate into other parts of the world, then they're just not going to have a big enough impact. All right, just my last slide. I've been working with engineers. Engineers do this a lot, and show a picture of all the people that they're working with. And you know, I think it's fun to have a big interdisciplinary team. So I wanted to give a shout out to Prabal Dutta, his awesome grad student Noah Klugman, who's really driven the GridWatch, and a lot of the other people on the team. All right, so I will stop sharing and happy to answer questions.
All right, well, I see a lot of the applauses symbols showing up on our reaction symbols showing up on Zoom, which is how we do our applauses now, but also some snaps for Professor Wolfram's excellent presentation. So I see a lot of hands have already gone up. For those of you not accustomed to being in the seminar, you're welcome to raise your hand and I'll call on you in the order that I see them show up, or you can use our chat function in Zoom, and I will look to the chat function as well and ask some of the questions from there. So based on the order in which I saw hands go up, we have Jean, Meg, and Greg. So Jean, I'd like to invite you to start with your question.
Thank you, Alyssa, and thank you, Dr. Wolfram, for your presentation. My question is on the challenges that you presented around measuring reliability, specifically around how utilities company also play a role. However, like you described in Kenya, there are a lot of differences between Kenyan utilities company and, for example, in developed countries and developed state like California. So how much do you see that improvements in regulatory standards around utilities companies can actually play a role in addressing this reliability?
Yeah, I mean, I guess I feel like you're a couple steps down the chain. I think we need to like we need to just understand basic patterns in reliability and basic statistics about reliability before we can think about what the right regulatory or administrative structure is. That said, I guess I think you got to be optimistic, and I am optimistic that you can do something to incentivize Kenya Power to provide better reliability. I think at the very least, we've seen in Ghana, so we're doing some kind of COVID-related surveys by phone recently over the past 6 months, and the Ghanaians have an election coming up December 7th. Electricity is a very hot button topic. So I think, you know, at the very least, there are public pressures and political pressures on those companies to do better. There's a headline that a colleague of mine sent me recently that basically said, you know, vote for the incumbent if you want better electricity. It's a huge issue. It's like talking about, you know, immigration or something in the US. It's something that's very much on people's minds. Wait, so Alyssa, do you want me to go through the order? You said Margaret or Greg was next?
I think it was me, so I guess I'll just go.
Yeah, I'm sorry, guys. I'm having very bad internet problems, so I've turned my video off and I've turned off my microphone in hopes of keeping it stable for everyone else. So please, Meg, and then Greg, and hopefully I'll be able to resolve this.
Awesome. Okay, well, thank you so much for that presentation. I think people really do throw around this idea that electricity leads to economic development a lot without examining it. So I really appreciate this study, and I think it was super interesting. I have two questions that are kind of related to just the complexity of doing research in other countries as a researcher based in the US. So one question, or so something I'm curious about, was that if the survey results were indicating that people did generally perceive an improvement in their overall well-being, but the other metrics like test scores or consumption of certain products weren't significant, I'm curious if there might have been other metrics that we could ask about instead that might be more reflective of what people value elsewhere, and how to approach that. And then my other question is just kind of how you navigate the ethical considerations of providing some people with access to electricity, but not others.
Yeah, those are two great questions. Okay, so on the first question, I agree that it's intriguing that we're seeing this result, that people are happier. I think there are a couple concerns about that. One is what's called experimenter demand effects. So, you know, we didn't come back and say, hey, we're the people that brought you free electricity. How's it going? Do you like it? But it wasn't, you know, it wasn't that far from that. I think they associate IPA with the survey NGO that we're working with bringing them free electricity. So it's possible that they said, yeah, things are going great, just because they knew that we were interviewing them. That's one possibility. A second possibility is that people feel happy because they have something that their neighbors don't. And so that what we're seeing is an impact that would not scale up if you were to bring everybody electricity. I guess the third possibility is that there, as you said, there's something else that they value that we haven't, that we haven't measured with our other metrics. And actually, I'm showing you results from the first 2 times that we did the surveys, and the final time that we did the surveys. We started asking, kind of along those lines, we started asking more detailed questions about safety, because we heard that people with, just a light bulb felt safer in their house. If they had an outdoor light bulb, they, there's a certain amount of belief in witchcraft in the areas that we're looking at. And so, maybe it was related to warding off witches, maybe it was related to warding off marauders, maybe, they just like to be able to see. So we see, some indication that that's true, that people feel safer with the electricity. And so that's valuable. On the ethical issues, I guess let me make a transition between your first question and your second question. I kind of comfort myself. So there are definitely, I have angst about this kind of colonialism, the people from California coming in and saying, okay, here's how you need to live your life and here's how you need to do things. So I guess I comfort myself by saying, I'm not telling people how to live their lives. I'm really just trying to understand it. And I'm trying to understand it, not, you know, I of course, have empathy for people who are less well off than me, but I don't want to pretend that I can tell them how to live their lives. I really just want to understand the electricity system because I'm worried about this global issue, because I'm thinking about climate change. So, you know, that's kind of what's going on in the back of my head. I still, never have I understood white privilege as much as like sitting in business meetings in places where whites are not dominant. There's definitely, yeah. Sometimes I worry even that people are telling me things like they've seen a lot of whites that are working on energy, and they know that they're always talking about solar. So sometimes I worry that they start talking to me about solar in a way that whatever, in a way that is not genuine to what they think about solar, but is kind of telling me what they think I want to hear. So I don't know. I try to be sensitive to those things. We've worked with this local NGO. I've teamed up with a development economist who's worked in the area of Kenya for 30 years, and I think we're pretty rigorous about designing survey questions that aren't leading, and designing survey questions that are culturally sensitive. I'm sure we could continue to improve, but we're trying to be sensitive to those things. On the ethics of the RCTs, so we have to put everything through the Committee for the Protection of Human Subjects, and I think they have the right metric. Like, yes, in some ways you are manipulating people's lives, and so that's a little uncomfortable, but there's you're manipulating them in a way to make some people better off, or at least we thought by bringing them electricity we were making them better off. So it's not like we're harming them. And the benefits of learning are I don't think you would get that insight without doing the RCT. I didn't get into this, but if you look at just like raw correlations in economic indicators like we have, and whether or not you have electricity, it looks like electricity is this huge transformative thing. But then you step back and think, well, it's the rich people who are getting the electricity. So it's completely confounded. I mean, we have a table in our paper where we show people that had electricity at baseline when we started, they had 17 more chickens and more bed nets, and like just everything was better, but they're also richer. They're the people that have decided to pay for the $400 connection. So, to me, the value of what you can learn through the RCT is high.
Thank you. That was a really good answer.
Thank you very much, Professor, for your presentation. It's very interesting, especially the results that this electrification isn't necessarily always as transformative as we think it may be. Thinking from the US context, I was just reflecting that perhaps one of the reasons that we think about that is because that in the US we had this rural electrification program that seemed to be highly successful and highly transformative in people's lives across the country. And I'm wondering whether there are any useful parallels that we can draw between maybe rural electrification in the US and how that program was implemented versus rural electrification in other parts of the world, and both in like how they might be similar, but also whether there's important differences between those types of programs.
Yeah, that's something that we've thought about a lot. And as I said, this research kind of forced us to ask more questions than it answered. So one of our conjectures about why we're seeing the low impacts or the zero impacts is, as I said, kind of related to income levels and related to the fact that people were using 3 kilowatt hours a month and just weren't buying appliances. So if you look at the US GDP in 1935 and in the 1930s, it was about 10 times higher than the Kenyan GDP currently. So, you know, it might just be that electricity can't be transformative until you reach some minimum threshold level of income and have the income to buy the appliances. Or I'm not sure that's it, the income to appliances, but it's consistent with there being some kind of minimum threshold level of income. We have a small amount of insight on that because remember how we had the 3 different categories of people that got electricity connections. Some of them got it for free, but some of them had to pay a good chunk of money. We still subsidize, but they had to pay, you know, $250. We saw higher impacts of the electrification on that subset of the people. We saw them like buying more appliances. We saw them starting businesses, in particular, women starting businesses. It's a tiny subset of our sample because not many people were able to spend $250 to buy to get the subsidized electricity connection. But, you know, again, as I was saying to Meg, if we think there's some kind of self-selection by income level into who gets electricity, the people who got it when we made them pay $250 versus the people who got it for free, the people who got it when we made them pay $250 are going to be wealthier on average. And so it's consistent, at least, with this idea of there being some kind of like minimum threshold level of income that you need to have before the electricity connection will be as transformative as it was. I guess the only other thing I'll say is that I've become aware that with the Rural Electrification Act in the US, there was also a program set up to subsidize loans for appliances. And so, you know, again, I think that's an important reminder that, as I like to say, people don't eat electricity. You don't just bring people electricity and then it makes their life get better. You have to buy things that use the electricity. And so you need to have the income or have some, you know, program to help you get the appliances that will use the electricity and get that much closer to impacting people's lives.
Thank you.
Great. I'm not sure if Alyssa's connection is still poor, so I wanted to ask one of the questions that came in through the chat from Facundo. It's a similar related question here. Thanks for the great talk. I wanted to ask, what do you think would have happened regarding the Kenyan experiment if before giving electricity to the communities, the sanitation and nutrition issues would have been addressed in those communities, or if an educational program would have been coordinated with the local government?
Yeah, those are great questions. I don't have any insight on what would have happened with sanitation and nutrition. The one thing that was going on in the communities that we are studying that's related to this, not exactly the same, is this. There's an NGO called Give Directly. It basically takes money from wealthy Silicon Valley philanthropists and gives it directly to people in rural sub-Saharan Africa. And they were working with some academic economists again and doing a randomized control trial to give that money to employ the Give Directly strategy for randomly selected households. And they're giving them a lot of money. I think they're giving them about $1,000, just like literally airdropping cash on people. And so we would have loved to see the interaction between our experiment and their experiment, like our people who had been given $1,000, like airdropped cash, are they better able to make use of the electricity? There wasn't enough overlap between their experiment and our experiment. But what we did see is that if you give people $1,000 in cash, it does improve their lives, unlike what we're seeing. But very, very few of those people use their $1,000 to buy an electricity connection. So it's consistent with this idea that there are other things that they want to do first before they get the electricity connection. So for instance, a lot of households that get the cash buy new roofs, like they buy a steel or metal roof and replace the thatched roof. But yeah, as I said, very few are using that money to get the electricity connection. And
Great.
I'm seeing the second part of the question, the idea of the educational program. Yeah, that's interesting. When we've described these results in Nairobi, we've gotten some kind of interesting reactions. It turns out that the area that we're working in Western Kenya it's the kind of hotbed of the opposition area. That there are very kind of well-defined tribal politics in Kenya. And so we're working in the area where the opposition party and the opposition tribes are predominant, and in Nairobi, and the ruling party, the other tribes are predominant. And so part of what the reaction is in Nairobi is like, oh yeah, those hicks, you know, it's as though like Biden supporters were told that Trump supporters were getting something of value and they didn't use it, and we'd be like, whatever, you know, they can't even process information or something like that. So yeah, so I guess the reason I brought that up is because I think kind of that reaction from people in Nairobi is, well, they just need to be educated about how to use electricity. So they're like these hicks that don't even know how to use the electricity. They just need to be educated about it. I'm not personally that optimistic about it, because there were people, you know, within this 400-meter radius that already had electricity. It's not as though I don't think that, I don't know, it's worth doing the experiment, I suppose, or doing more investigation on this, but my guess is that education is not what needs to happen.
Great. So if we have time for a few more questions. So, I see Daniel Simpson. Go ahead, Daniel.
Hey, thank you for the talk. Very, very great. Actually, it's interesting. My question kind of directly related to what you were just talking about. And I was wondering if you were thinking about reconducting the experiment in a different area to see if local socio-regional behavior patterns sort of affected your results.
Yeah, I would love to replicate this study. We were in negotiations with people from the Ministry of Energy about doing a nationwide version of the study, and that fell through, unfortunately. There's work from India that's looked at a nationwide rollout of a program, of a rural electrification program there, that's found pretty similar results to ours, kind of like these depressing zero impacts. And it's probably, I don't know, too early to discuss this, but I'm very recently started working on a project with a donor that wants to connect urban customers and with a focus on non-residential, on kind of micro enterprises and small enterprises. So yeah, I'm more optimistic that we would have that electrification would have an impact there. You can imagine, you know, if you take a tailor and they had been using a foot pedal sewing machine and you give an electric sewing machine, that they just become that much more productive. So yeah, stay tuned. It'll be a couple of years, but yeah, I guess I think we've looked at one sector, and as you're saying, there are other parts of the country, there are other sectors, there's the non-residential, there's, you know, you can think about hospitals, you can think about schools, there are other areas to look for potential impacts of electrification.